nVidia's Rubin AI GPU, a glimpse into the future.
Have you been following nVidia's latest developments? I've been reading about their next-generation AI GPU, Rubin, and it sounds like a major leap forward.
Yes, it's quite exciting. Rubin is set to be the successor to their Blackwell architecture, which is already incredibly powerful. I believe it's named after the astrophysicist Vera Rubin, which is a nice touch. It's interesting how quickly nVidia is pushing these architectures out.
Absolutely. The roadmap shows a relentless pace. Rubin is slated for release in 2026, though there were rumors it might arrive 6 months ahead of schedule. nVidia's official word is that Rubin is on track. This rapid cadence highlights the intense demand in the AI space.
What really stands out to me about Rubin are the core technologies they're employing. It's leveraging TSMC's advanced N3P and N5B processes, with the compute chips on N3P and I/O chips on the more economical N5B. This mixed process node design allows for optimizing performance and cost.
That makes sense. These are essentially 3 nm class fabrication processes. And the packaging is equally impressive. Rubin will use SoIC, System on Integrated Chips, 3D vertical stacking, which integrates multiple processing cores to shorten signal transmission times and improve data processing efficiency. It also incorporates CoWoS, chip on wafer on substrate, packaging, which is crucial for connecting the high bandwidth memory.
The SoIC and CoWoS technologies are critical for high-performance AI chips. TSMC's capacity for SoIC is projected to significantly increase, aiming for 15,000 to 20,000 wafers per month by late 2025 and doubling in 2026, which is essential to support nVidia and other chipmakers.
Looking at the performance projections, the VR200 Rubin is expected to deliver 50 pfLOPS in FP4 for bit floating point math for inference workloads and around 17 INT8 pfLOPS for training. That's a huge jump from Blackwell's 20 pfLOPS.
And the Rubin Ultra, VR300, which follows in 2027, is set to double that, promising 100 pfLOPS at FP4 performance. However, this immense power comes with a significant trade-off in power consumption. The VR200 is projected to consume 1,800 watts per GPU, and the VR300 an astonishing 3,600 watts per package. Data centers will certainly face challenges in feeding and cooling these colossal chips.
Indeed. nVidia is reportedly focusing on managing this extreme power consumption for the Rubin GPUs. It's a testament to the insatiable demand for processing power and AI that companies are willing to push these limits.
The memory story for Rubin is also quite advanced. It will utilize HBM4 memory, with the VR200 featuring 288 GB in 8 stacks. The Rubin Ultra will go even further with 1 TB of HBM4E memory per package across 16 stacks.
And the bandwidth is just incredible. The VR200 is expected to reach around 13 terabytes per second, while the Rubin Ultra will hit 32 terabytes per second. This high-bandwidth memory is absolutely critical for handling the massive datasets required for AI model training. It's also interesting to see the competition among HBM suppliers. Samsung reportedly passed nVidia's HBM4 sample tests, while SK Hynix already delivered samples and is set for mass production in October. Micron also shipped HBM4 samples.
Yes, and there are even rumors that nVidia itself is developing its own HBM-based die on a 3 nm node for trial production in late 2027, which could impact the memory and chip markets.
Rubin won't operate in isolation, it's part of a larger ecosystem. It will be paired with nVidia's new Vera CPUs, which will feature 88 custom ARM cores and a 1.8 terabytes per second NVLink C2C interface.
And the interconnects are scaling up too. Rubin will introduce NVLink 6.0, boosting bandwidth to 3.6 terabytes per second bidirectional, while Rubin Ultra will move to NVLink 7.0. Beyond the local connections, the Rubin generation will also shift to Spectrum 9 photonics and Quantum X photonics networking platforms to enable exascale data centers. These new networking technologies can deliver immense bandwidth, up to 1.6 terabytes per second per port and a total of 400 TB per second.
All of this culminates in the system designs. nVidia is planning Vera Rubin NVL144 systems, packing 144 Rubin GPUs. Then, for 2027, the incredibly powerful Rubin Ultra NVL576 Kyber racks will integrate 144 quad-chiplet Rubin Ultra GPUs, which is equivalent to 576 compute GPU chiplets. These Kyber systems are projected to offer 14 times the performance of current Blackwell NVL72 platforms.
This aggressive roadmap, especially with Rubin, really solidifies NVIDIA's leadership in high-performance computing and is set to drive changes in AI GPU industry standards. They already dominate a significant portion of the AI accelerator chip market, with 90% of them using TSMC's advanced nodes and CoWoS packaging.
It certainly speaks to NVIDIA's full-stack AI approach, integrating compute, networking, and software solutions. Their CUDA software ecosystem, often referred to as a moat, is a significant competitive advantage that makes it hard for rivals like AMD and Intel to catch up.
Indeed. The sheer insatiable demand generated by the AI revolution continues to fuel this rapid innovation and investment. NVIDIA's consistent outperformance and strategic maneuvers, like the Rubin platform, show their commitment to maintaining their competitive edge in this incredibly high-stakes industry.
It's a fascinating time to watch these titans navigate the bleeding edge of technology, particularly as AI continues to redefine the entire semiconductor landscape.